Hello students, welcome back to our Edustar YouTube channel. If you are visiting our channel for the first time, make sure to subscribe to the channel and share it with your friends. You can also join to our WhatsApp group. The link is in the description and comment section. Alright, let's get straight into the video. In this video, we will be covering discrete mathematical structure. The subject code is BCS405A, Module 1 Fundamentals of Logic. In this module, we will be covering tautology. Tautology definition is a compound proposition which is true false of all the possible truth value of its component is called tautology. We will be solving two problems in this video. First problem is prove that for any proposition P, Q, R, the compound proposition P implies Q and Q implies R implies P implies R is tautology. We have to prove this one. So for this, I'll give the hint. For P implies Q, P must be 1 and Q must be 0. For Q implies R, Q must be 1 and R must be 0. For P implies R, P must be 1, R must be 0. And means it is a multiplication. Now we should put the values for P, Q and R. We know the binary values for P, Q and R. And next is first we have to find the P implies Q. P implies Q means P should be 1 and Q should be 0. For that value we should put 0 value. We will be searching now P1 and Q0, here 0. So for this the value is 0 and P1 Q0, that is the value is 0. For remaining values we should put 1. Next, Q implies R. For Q implies R, Q should be 1 and R should be 0. Q should be 1, R should be 0. For this value is 0. Q should be 1 and R should be 0. The value is 0. And for the remaining 1. And next, P implies R. For P implies R, P should be 1 and R should be 0. P should be 1 and R should be 0. We have to search here. Fifth. For remaining 1, 2, 3, 4, 0. And P should be 1, R should be 0. Next, we have to find out this one, that is P implies Q and with Q implies R. And means multiplication, that is P implies Q and Q implies R. These two should be multiplied. 1 into 1, 1. 1 into 1, 1. 1 into 0, 0. 1 into 1, 1. 0 into 1, 0. 0 into 1, 0, 1 into 0, 0, and 1 into 1, 1. Next, we should find the old term. Means we should prove that this is a tautology. So we should next prove that one, okay? That is and with Q this implies this, means this value should be 1 and this value should be 0. We should search for it. This value should be 1 and this value should be 0. There is no terms like that, so all the values are 1. So for all the values 1 1 1 it comes, means that is proved as tautology. This is the very important problem in this module. They have asked several times, and we should write the conclusion at the last, that is it is a tautology. So the second problem is, this one. Prove that for any three proposition P or with Q and with P implies R and with Q implies R, this all implies with R. It is a tautology, we have to prove that. Here also three propositions are there, P, Q and R. For P, Q and R, we know the values. Next, first we have to prove this one, P or with Q. P or with Q means we have to add it. Means P or with Q means 0 plus 0, 0, 0 plus 0, 0, 0 plus 1, 1, 0 plus 1, 1, 1 plus 0, 1, 1 plus 0, 1, 1 plus 1, 1, 1 plus 1, 1. Next, we should find this one. P implies R. As previously I told you, P implies R means P should be 1 and R should be 0. Here we have to search for it. P should be 1 and R should be 0 is this one. For 0, I'll write the values 1. P should be 1 and R should be 0 for the 0. 1, 0 and 1. Next is Q implies R. Q implies R means Q should be 1 and R should be 0. Q should be 1, R should be 0. That is 0. Sorry. Don't skip the video for more better understanding. Q should be 1 and R should be 0, that is 0 and 0. And next we should find this one, that is P implies R and with Q implies R. That is and means multiplication. 1 into 1, 1, 1 into 1, 1, 1 into 0, 0, 1 into 1, 1, 1 into 1, 1, 0 into 1, 0, 0 into 1, 0, 1 into 1, 1, 0 into 0, 0, 1 into 1, 1. Next is we should find this value. That is, this value is and with this value. And means multiplication. We should write every step in this. Zero into 1, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1, 1 into 0, 0, 1 into 1, 1, and 1 into 0, 0, 1 into 1 is 1. Now we should prove this implies this one. This implies this one means this should be 1 and this R should be 0. Means this here 1 and R is 0. We have to find that value. Is there any value like that? We should find. There is no value like that, so for all that we have to write 1 1 1 1. We should write the whole problem. And this is last at conclusion. Therefore it is a tautology, hence it is proved. There is a small topic. Along with tautology they will ask contradiction. Contradiction is nothing but for tautology the value should be 1, for contradiction its opposite means 0 0 0. I'll explain one example for that and I'll write one definition. A compound proposition which is false for all possible truth values of its components is called contradiction. Means there should be a false for all truth values. I will show you one example. In the problem it will be covering tautology and contradiction both. I have already prepared the question for this. Show that for any proposition P and Q, P implies P or with Q is a tautology and P and with negation of P and with Q is a contradiction. I have already prepared it. For two proposition only 4 values. P or with Q means it is addition. 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1. P implies P or with Q means P should be 1 and P or with Q should be 0. Is there any value like that? No. So for all that it is 1. And next negation P means opposite of P. 1 1 0 0. And negation P and with Q. Negation P and with Q means negation P and with Q. 0 into 1 0, 1 into 1 1, 0 into 0 0, 1 into 0 0. Next P and with negation P and with Q means this one. P and with negation P and with Q. So multiplication 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 0 0. That is proved that what they have asked. Show that for any proposition P and Q, P implies P or with Q should be tautology. Tautology, therefore it is proven. And P and with negation P and with Q should be a contradiction. Does that prove this? Yes, it is a contradiction. Therefore, we have solved 3 problems in this video. Thank you students. Let's see you in the next video.